Hello everyone, welcome to this video on the set theory. This video is brought to you by Learning Made Easy team, a team of IIM grads in association with the e-learning partner GTCUBE Get to the Top. If you are watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of the course and also get to practice a lot of questions on these concepts that would give you a good practice and also help you understand these concepts better. So let's get started. So first let's try to understand some basic things about a set. So first, what is a set, right? That's a very important thing that we need to understand. So set is basically, a collection of elements, right? It could be, those elements could be selected based on certain, properties or certain similarities. Let's say if I say there's a set A, which is, basically collection of even numbers at less than 20, right? So what will be set? Basically set A elements would be 2. Okay, let me write it like positive even numbers, to make it exactly correct. So A is basically a set of positive even numbers which are less than 20. So 2, 4, 6, 8 and so on up to 18 would be my elements of set A, right? So you could see the list of elements, or you could also see the definition of a set, which would say set is basically, like a set A is defined as collection of all the positive even numbers which are less than 20. So that's basically one way to write. So I write it like this, right? We see brackets, curly brackets with all the elements being listed. Or I could also define set A is equals to set of positive, even numbers which are less than 20, right? So that's how we could also define the set. And then, as I said, there will be elements inside a set. So let's say if I know there is an element 2 which is part of set A, right? So basically it's called 2 is element obviously, but I can also say it's a subset of A, right? So let's define another set B, which is basically consisting of elements like 2 and 4, right? So see, the 2 and 4 are already the elements of A, so I can say B is subset of A. That is, every element of B is part of A or set A. That's when I call it B subset of A. That is basically, I would say B is subset of A. We write it like this. That's basically B is subset of A. Then if I want to say that there's one element which belongs to set A, then we write like this: 2 belongs to set A. This is epsilon, is a Greek letter, but we call it belongs to. So this element belongs to set A. Or I can also say 5. Okay, 5 does not belong, right? So 5 does not belong to set A is the way you write it. You cut it off and then you say that it does not belong to set A. So basically just understand set is basically collection of elements, right? I can also have a null set, right? That is also, a possibility. That is, there's a set A which has no element in it, right? If I define set A as positive numbers, right, less than 0, is there any number which is positive and that is less than 0? No, right? So basically I should put it like this: A is a null set. So basically phi is the symbol I use. I put that this is a null set so that I understand, okay, there is no element in this set A, right? So basically just understand set is consisting of some elements which would be coming based on how the set is defined using some definition. There is a possibility for null set also, and there could be multiple sets, and there is something called universal set. So that is basically, talked about when I'm trying to define everything in this world is, defined in the universal set. So not really like everything. I could also define a new universe which consists of only even numbers, right? Then I'm not worrying about 3, 5, 7, etc. I'll only look at the even numbers. So this is how I define this universe. Just be careful of how the universe is defined. That just depends on the statements given in the question and etc. Right, so now let's get to some basic operations, right? Union, intersection, all of these are common things that you keep using, keep listening, keep seeing in set theory. So first is this: basically it says, I am basically talking about there are two sets A and B. There are two different sets, right? And now this is basically talking about A union B. U is called as union. That's basically, in plain English you can understand, it is A or B, sorry, A or B. It's basically A or B, right? So what does that mean? Venn diagrams, you draw it like this. This is the entire universe, right? I'm picturing everything inside this rectangular box, and A is consisting some numbers or some elements which would be part of this universe, but it is not complete universe. That's why I'm drawing a circle, right? So if this is the entire universe, let's say universe is defined as numbers from 1 to 10, right? So let's define set A, which is basically 1, 2, 3, 4 and 5. So 5 numbers are there in the set A, 5 elements, which is part of this universe, but not every element of the universe. So I picture this set A with A, right? So this one includes 1, 2, 3, 4 and 5. Let's say there's one more set B, which is defined as 4, 5, 6 and 7, right? So I'm defining another set B, which has 4 elements, 4, 5, 6, 7. So the way it should look like is this: 6, 7, 5 and 4. Why am I writing 4 and 5 here? Because 4 and 5 are the common elements in both, right? So there is this overlap coming because of that reason. If I have set C, let's say, which is basically 8, 9 and 10, and I am drawing A and C only, A will be here and C will be somewhere here. They don't touch each other because there is no common element between these two, right? So that's when I don't touch each other. But because I know that 4 and 5 are the common elements in these two, I have drawn such a way that they are overlapping each other. So coming back to this, what is A union B? Basically all the elements which are present at least in one of these two. From this example, what is A union B? A union B would definitely have 1 because 1 is present at least in A, 2 is present, 3 is present, 4 is present and 5 is present. 4 and 5 are already noted down, 6 and 7 are also present in B, so I should also count that. As I said, 7 is present in B but not in A, that is fine. 6 is present in B, not in A, that is fine. 2 is present in A, not in B, that is fine. That is also counted. We don't only count the numbers which are repeating in both, right? Elements present even in one of those two sets are counted in A union B, or union case. When it comes to intersection, so that's why when I draw picture, the A union B is basically everything, all of this, right? That's why the color is done for the entire two circles, right? If you see 1, 2, 3, 4 and 5 is the common, 6, 7, I have to include all of these elements, right? That's why I count the entire area that's coming in this overlapping zone as well as the individual circular zones as well. That's A union B. A intersection B, the inverse U is called intersection, right? It's basically, in plain English, it would turn out to be A and B. I need to pick the elements which are common in both. If they are present only in one of those two sets, I will not count them. They have to be present in both. So in this example, what will be the A union B? It's only 4 and 5, right? Because 4 is present in both and 5 is present in both, but none of the other elements in A and B are present in both the sets. So A union B is only 4, 5, so that's why I write this is the overlap zone. Right? This is the entire B, this is the entire A. What is that common is this zone, right, which is common in both. That's why this is A intersection B. This one is everything A union B. That's how we draw when I have to say. And as I've shown here, right, A and C are not touching each other because A is 1, 2, 3, 4, 5, C is 8, 9, 10. These are called disjoint sets, right? A union C will still be the same. As I said, I write every element which is at least appearing once. So 1, 2, 3, 4, 5, 8, 9, 10 is what A union C is. A intersection C will be null set, and there will be nothing in this because they are not touching each other. There is no common element. You see 1, 2, 3, 4, 5 are not repeating in C, 8, 9, 10 are not repeating in A. That's why it's basically null set. A intersection C is null. That's why these are called disjoint sets. Then other thing is A minus B. So let's take the same example. A is 1, 2, 3, 4 and 5 and B is 4, 5, 6, 7, 8 or something. Okay. Now what do I mean by A minus B? See from the set A, right, remove the elements which are present in B. That is basically from the entire set A, remove this part. That turns out to be like A minus A intersection B. whatever the elements are present in both, eliminate them from A, and whatever the net result you get would be the answer for this, right? This is what A minus B. See, 1 is not present in B and A. I mean to say it's not the common element, so I will write 1. 2 is not common, 3 is not common, 4 is present in B also, so that will get cancelled out, and 5 will also get cancelled out. 5 will get cancelled out, 4 will get cancelled out. A minus B is just 1, 2, 3, which is what this is, right? As I said, 1, 2, 3 is this is 4 and 5, this is 6, 7 and 8. So we are writing only this zone, right? So that's why it's only 1, 2 and 3. And then finally this is called, okay, let me talk about B minus A. What would we get for B minus A? B minus A would be this zone. This and this. As I've written 6, 7, 8 would be the answer, but let me again show it. So from B, when I remove, I should remove only the elements which are present in A. 4 is already there in A, 5 is already there in A, so I would remove them. 6 is not present in A, 7 is not present in A, and 8 is not present in A. So B minus A would come out to be 6, 7, 8. Right. Finally, this is complement. So if I know A, universe I have defined, right, like 1, 2 and so on up to 10, and A is defined as 1, 2, 3, 4, 5. So all these 5 elements will be present here, and universe, as I said, is this entire rectangle, which would have 1, 2, 3, 4, 5 in this circle. The remaining 6, 7, 8, 9 and 10 will be spread out in this shaded zone, right? That is this zone. So that's the complement of A. What is complement of A? That's, we write like this. A complement is 6, 7, 8, 9 and 10. Universe minus A. That's how you understand it. It is also denoted by A dash or AC subscript, superscript. Basically, we have to remove from the universe, remove all the elements of A, and whatever is left out is the A complement. Right, for the B complement, similarly, remove from the universe B elements. So 4, 5, 6, 7, 8 should be removed. So I will have 1, 2, 3, 9 and 10. Right, these are the B complement for this if B is defined as so. Right, these are the very basic things that you need to know. Right, on top of this, we will solve some problems to make you understand how to do some basic operations. Right. So this question is on the very basics of set. So A is 1, 2, 3, 4, 5, 6. B is another set 3, 5, 7, 9, 11, 13, and C is 2, 4, 6, 8, 10. They are asking us to find A minus B. A is this, right? 1, 2, 3, 4, 5, 6. I just need to remove the elements which are present in B in A minus B. Right? 1 is not present here, so I will include it. 2 is not present in B, I will include it. 3 is present in B, so I should not include it. 4 is not present in B, I will include it. 5 is part of B, so I will not include it. 6 is not present in B, I will include this. So A minus B is 1, 2, 4, 6. A union B. As I said, A union B is basically A or B, right? Even the element is present in one of these two sets, we'll count that. 1, 2, 3, 4, 5, 6. I'll write everything already which is part of A. Then I'll write other elements which are not present in A. Like 3, 5 is already counted here, so I will not write them. 7, 9, 11, 13 are not counted in A, so I will write 7, 9, 11, 13. This is A union B. What about A intersection C? They said A intersection C is basically A and C. Whatever the element I pick in A intersection C should be present in both A and C. 1 is present in A but not in C. 2 is present in A and C also, so that's part of it. 3 not present in C. 4 is present in both A and C, so I will count that. 5 is not present in C, and 6 is present in C. Yes. So automatically I don't need to even see 8 and 10 are anywhere not present here. So that's basically A intersection C is 2, 4 and 6. The last one is slightly complicated. It is saying B minus C union A. So start with this B minus C. First find out what is B minus C. Right, I know B is 3, 5, 7. B is 3, 5, 7, 9, 11, 13. Minus C, I just need to remove the elements which are present in C. 2 is not present here. 4 is not present here. 6 is not present here. 8 is not present here. 10 is not present here. So basically nothing is present in B which is part of C, so B minus C is simply B itself, right? Because here I don't see any of these elements in C, so I cannot remove any of them, so it will turn out to be as simple as the same as B. Now I need to do B minus C is this union A. So this is B minus C is B, union A is basically same as this, whatever we'll ultimately get the same thing. B minus C union A, I know B minus C is this, A is this, right, all of that, B minus C union A will turn out to be 3, 5, 7, 9, 11, 13. 3 is already counted, 5 is already counted. Removing these two, I need to write 1, 2, 4 and 6 in this, which is what we've already written here, right? A union B, B union A. Here B minus C is anyway B, that's why you're going to get the same answer. That's why the answer is this for the B minus C union A. Right? So very simple thing. Once you understand them properly, you'll be able to do it very easily. So thank you for watching this video. If you're watching this video in the YouTube channel, make sure that you check out our full-length courses available for free at gtcube.com/store, where you'll get to watch these videos as part of the course and also get to practice a lot of questions on these concepts. Also like our partners Facebook page, facebook.com/gtcube3. We're coming up with a lot of content that would help you in your preparation. All the updates and notifications will be shared over there, so don't miss that. So thank you for watching and let's meet in the next video.